Today we'll look at applications of quadratics. Warm up. A ball is sent into the air with an initial upward velocity of 48 feet per second. Its height, h, in feet after t seconds is given by this function. H of t equals negative 16t squared plus 48t plus 4. A, what's the starting height of the ball? How could you mathematically show this? All right, so the starting height is at time 0. So if we're plugging into this function, we can say h of 0, the height at time 0, equals, and then plug in a 0 everywhere we see the t. So negative 16 times 0 squared plus 48 times 0 plus 4. So if we're multiplying this out, notice we have two numbers here times 0, and those would just cancel, right? 0 times anything is 0. So the height at time 0 would be 4 feet. So standard form will give us the y-intercept. The y-intercept will be that number, the c value, the number by itself. What height will the ball be when 2 seconds has passed? How can you figure this out? So again, we can just plug into the function. Instead of a 0 for time, we can plug in a 2. So h of 2 equals negative 16 times 2 squared plus 48 times 2 plus 4. So again, if you have a graphing calculator, you can just type that in. So we have negative 16, and it was 2 squared times 2 squared plus 48 times 2 plus 4. So at 2 seconds, that ball is 36 feet high. C, sketch a picture of this function. Okay, so the starting value is 4, and at 2 feet it's 36, or 2 seconds it's 36 feet high, but again, we're just making a sketch, so let's go like this. So this is height over time. We start at 4, it's going to go up and then go down. So we can extend that over here. Okay. In how many seconds will the ball reach its maximum height? Okay, so the maximum is the vertex. And in the vertex, you have your x value and your y value, where x is the time and y is the height at that time. Again, we can see x time, y height. All right, so maximum height, and this is what we looked at yesterday. This is the vertex. And how do we find the vertex from standard form? We can do opposite b over 2a. So let's take a look at our function right here. The b value is 48. The a value is 16. So let's plug in. So opposite 48 over 2 times negative 16. Let's multiply that out. Negative 48 divided by negative 32. And that's 1.5 seconds. So at 1.5 seconds, that ball reaches its max height. What is the ball's maximum height? Okay, so again, we see the height is the y value. And again, we looked at when we found the vertex that the y value is just plugging in. So we're just plugging in 1.5 for every x that we see in the, or t here, in the original function. So negative 16 times 1.5 squared plus 48 times 1.5 plus the 4 for the starting value. And again, we can just type that in here. Negative 16 times 1.5 squared plus 48 times 1.5 plus, I did 0.5, and then plus 4. All right, so 40 feet is the highest it will reach at time 1.5. Okay, so that vertex is as 1.5, 40. At 2 seconds, if you remember, it was already at 36 feet. Okay, when will the ball reach the ground? Is that the max height, which is the vertex, or is it an x-intercept? Okay, so where it will reach the ground, it's going to be right here, and that's an x-intercept. How do we find x-intercepts if it's in standard form? We use quadratic formula. So it's an x-intercept quadratic formula. So x equals opposite b And what was b again? It was 48, so negative 48 plus or minus the square root of b squared minus 4 times a times c all over 2a. Again, you will want to calculate these three numbers right here to minimize any error. So we'll have x equals negative 48 plus or minus the square root. I'm just going to type in that discriminant. 48 squared minus 4 times negative 16 times 4. That's 2,560 all over 2 times 4, which is 8. Once you have these numbers, you can split it up. So for the first one, we'll do negative 48 plus the square root of 2,560. Hit enter. Divide by 8. So that's about 0.324. If I type that in right, that's okay. Let's do negative 48 minus the square root of 2,560. Hit enter. Divide by 8. And that's, I feel like we need to recalculate this because what I'm getting, okay, so what I got for this one was negative 12.3246. And it makes sense one is negative because if you look, we have one negative here. But we knew our vertex was at 1.5 seconds, so a time of 0.324 is not right. So let's just make sure I plugged in correctly. Okay, so x equals opposite b, so negative 48, that's right, plus or minus the square root of 4 squared, no, not 4 squared, of 4 times a, which is negative 16, times c, which is 4. Yeah, let's try one more time. 48 squared minus 4 times negative 48 squared minus 4 times negative 16 times 4. That's right. And it's negative 48 plus the square root of that divided by, oh, that's why, because I put the wrong value in for the a value. It's negative 16. Silly me. All right, so negative 16, which changes this. This should be negative 32. Recalculate. That's why these are wrong. The answers didn't make sense. Okay, let's try it again. Negative 48 plus the square root of 2,560. Hit enter. Divided by negative 32. Okay, so one answer is negative 0.08, which is this x-intercept over here. The other one we should expect to be positive. It should be bigger than 1.5. So negative 48 plus the square root of 2,560. Hit enter. I did plus already, so minus that. Hit enter. Divide by negative 32. Okay, that makes more sense. So we get about 3.08 seconds when it hits the ground. Another way to think about this as well, so this time is 3.08 seconds. It has a height of 0. Another way to think about it too is we know that the vertex is the exact middle. So here's the line of symmetry here, this middle line right here was at about 1.5 seconds. And if you double that, you get your 3 seconds when it hits the ground. So if you can figure out the x value of the vertex, it's going to hit the ground when you double it, just because that is the line of symmetry to the middle. Okay, so we're going to take that today and look at it in context. So that was a context problem where the ball hits the ground. Here's another one called Math and Basketball. So we're going to watch the video, and then we're going to calculate Elton Brand's basketball problem. So here's the video.
I'm Elton Brand. I'm a power forward in the NBA. I'm here in my hometown, Peekskill, New York, visiting my old high school. I started playing basketball when I was about 5-6 years old, and I was really, really bad. But learned the game and kept working at it and got better and better as I got older. I started out high school on the junior varsity team. Then the coach from the varsity team brought me up to that level. The following 2 years, we won the New York State Championship, which put me on the national spotlight and my team. So after high school, I accepted a scholarship to Duke University, got to college and played really, really well and became the #1 pick out of all the collegiate players and got drafted by the Chicago Bulls #1 overall. And it was a dream come true. As anyone that follows sports statistics knows, There's a lot of math in basketball. Free throw shooting is a skill that every basketball player has to work on. I don't constantly think about the math behind it when I'm playing a game. But when I was younger, understanding math helped me improve my performance. 3 key variables can influence your shot. First is the release height. Second is the ball's initial vertical velocity, a rate that includes the angle and speed of the ball as it leaves your hand. And the third is gravity, which makes a basketball accelerate as it falls. You can use these variables to figure out the height of the ball at any given time. And knowing that, you can tell if you'll make the shot. When I shoot a free throw, my goal is to maximize the height of the ball so it has the best chance of going in. Your challenge is to use the 3 key variables and my stats to figure out the maximum height the ball reaches on its way into the basket. At release, my average initial vertical velocity is 24 feet per second. My average release height is 7 feet. The free throw line is 15 feet from the backboard. The height of the basketball hoop is 10 feet off the floor, and the rim is 18 inches in diameter. And finally, you can find the height of the ball at each point in time by combining the 3 key variables. The acceleration of gravity, which is negative 32 t squared, but in this case, you'd use only half for downward pull, or negative 16 t squared. The initial vertical velocity, which you'd multiply by time to get the distance traveled, and the release height. All right, get to work.
Okay, so I wrote down, like you said, the 3 key variables. The acceleration of gravity downward is negative 16 feet per second squared. His initial vertical velocity, the speed at which he releases the ball, 24 feet per second, and his release height, 7 feet. So when we write the equation, gravity comes first, negative 16 t squared, there's the quadratic part, plus 24t plus 7. All right, so we're going to graph what the situation looks like. All right, so here, got room here. Oh, I have a lot of room. All right, so here's Alton Brand. He's shooting the ball here. Release height is 7 feet. The ball's going to go up, and then hopefully it goes through the hoop, which is 10 feet tall. I should have done that a little bit taller. Okay. Okay. Here's my basketball. Okay, how tall is this? This is 10 feet tall. Okay, so here's the situation of what it looks like. He's 15 feet away from the basket as well. Okay, so now with that, we're going to plan it out. What strategy will you use to calculate the value of time when the ball reaches a height of 10 feet? All right, so there's 3 questions we're going to answer. What time does the ball reach 10 feet? Because that is when the ball hits the basket at 10 feet. All right, so if you write the equation, again, it was negative 16t squared plus the 24t plus his release height of 7. We want to know when that equals 10. So if you recall, we're going to use quadratic formula. Essentially, here's what we're solving right here. If we were to graph it, it's like the x-intercept, but it's shifted up 10 feet. So we do have to shift it back down, so it's actually like on the x-axis. So our first step is we will subtract 10 from each side, so we can get 0 on one side and use quadratic formula. So we have negative 16t squared plus 24t minus 3 equals 0. And then we're going to use quadratic formula to solve. All right, solve your problem, show your steps. You may use the graph on the last page. Or show your work. Okay, so again, quadratic formula we're going to use to solve. And in order to use that, we need 3 variables, a, b, and c. So a is the negative 16, b is the 24, and c is the negative 3 because we subtracted 10 from each side. We're going to plug into quadratic formula. X equals opposite b plus or minus the square root of b squared minus 4 times a times c all over 2a. All right, now we solve. Remember to get these 3 numbers right here. X equals negative 24 plus or minus the square root, and we'll get the discriminant. So we'll type in 24 squared minus 4 times negative 16 times negative 3. Okay, so that discriminant is 384 all over negative 32. And then we can go ahead and calculate our 2 answers. I'll go this way since we have room. The first one's negative 24 plus the square root of 384, hit enter, divide by negative 32. So our first answer is 0.1376 seconds. And then the other answer is negative 24 minus the square root of 384. We'll hit enter, divide by negative 32. 1.36237. I'll just leave it like that. I guess get around to 4. All right, so the question is, and this is for time, what do these two answers mean? And if we go back to the graph, one is at 0.13 seconds, almost right away. So here's 10 feet, right? So almost right away at 0.13 seconds, it hits 10 feet. It's going to go up and then hit 10 feet again when hopefully it goes in the basket, and that's at 1.36 seconds. So it only takes 1.3 seconds to get to the hoop. All right. Your solution, there are two times when it says to round to the nearest hundredth. So time will be at 0.14 if you round to the nearest hundredth, and 1.36 seconds. How could you find the time at a certain height on a calculator? You could type in this equation right here on Desmos or on the graphing calculator, and then type in 10 or y equals 10 to see when they intersect. And see where they cross. So that's one way to do it. Maybe I'll just show you. Okay, so on Desmos, we'll graph the equation, and I'll change everything to y equals and x equals, or y is an x's. So you have negative 16 x squared plus 24x plus 4. And we want to know when it hits 10 feet. Okay, so y equals 10, and if we zoom in a little bit, we can find the point of, find the point of intersections. We should get our two answers. So there's the, oh, I typed in the wrong equation, didn't I? Yes, I did. Did I type in the wrong equation? Yes, I did. So it was 24 plus 7, not 4. Okay. So here are two answers, the 0.138 and the 1.362 at 10 feet. So there's another way to do it. All right, let's take a look then at the next question. Okay, at what time does the ball reach its maximum height? Okay, so let's go back to our graph, and that's the vertex. Let's do that in red. All right, so vertex and time is the independent variable. So here's time. So we want the x value. So if it asks us right here, plan it out. Okay, so this is the vertex, which is the x value, which is opposite b over 2a. All right, so let's do it. Let's plug in. X equals opposite b, and the b value in the original equation right here is 24, and the a value is negative 16. So we have 24 over 2a. Okay, and then we'll simplify that, so that's negative 24 divided by negative 32. Okay, so at 0.75 seconds, that ball reaches its maximum height. Okay, and then it says, what is the maximum height? So we found the time at which it reaches its maximum height, but what is the actual height at that time? So you have to plug in 0.75 for x, in this case for t, and then solve for the height. So here's what it looks like. If this was our function, h of t equals that negative 16t squared plus the 24t plus the 4. For every value of t right here, we're going to plug in that time at which it reached its maximum, which is 0.75. So h of 0.75 equals negative 16 times 0.75 squared plus 24 times 0.75 plus 4. Okay, let's calculate that. We'll type it in the calculator, use the parentheses, plus 24.75 plus 4. All right, so I typed it in, and 13 feet I got to be the maximum height of the basketball. All right, so if we go back to our lovely diagram here, the vertex would be 0.75. At 0.75 seconds, it reaches a maximum height of 13 feet, and that starts going down again. How could we do it on the graphing calculator? Well, we have it typed in. We can just click on the max height right here. So 0.75, ooh, 16. Good thing we checked our answer, so let's just double check that I put the math in right. Okay. Oh yeah, I keep using the +4. Okay, so we're going to change this. I don't know why I keep putting +4. It's 7 feet. It was his release height. So double check. We'll type this in again, and we should get 16. So negative 16 times 0.75 squared plus 24 times 0.75 plus 7 was his release height, and we do get 16. So his the maximum height of the ball is actually 16 feet, not 13. Let's go back up to our picture and adjust 16 feet. Okay. And lastly, if there was no hoop, when would the ball land on the ground? So like he made an air ball, or again, if there was no hoop, and when would it land on the ground? That's an x-intercept. To find an x-intercept, we use quadratic formula. So our last step here, let's make this bigger here. Okay, so this is quadratic formula. Oopsies. Okay, so when the height is 0, we want the time. That's using quadratic formula. So x equals opposite b plus or minus the square root of b squared minus 4 times a times c, 7 is c, not 4, all over 2a. All right, so we're going to plug in his numbers. Use quadratic formula to solve. Remember to calculate these three numbers. So we have negative 20. Oh, first let's do the discriminant. 48 squared minus 4 times negative 16 times 7. So x equals negative 24 plus or minus the square root of the discriminant is 2752 all over 14. We're going to split it up and get our two answers when the height is 0. So negative 24 plus the square root of 2,752, hit enter, divided by 14, and it's at 2.0328 seconds, and negative 24 minus the square root of 2752, hit enter, divided by 14, and we'll get negative 5.46, and we're going to look at the positive time. The reason why 1 is negative is because if you think about our picture right here, since we started with a height at 7 feet, like here's the height at 7 feet, if you go backwards, you'll see that one x-intercept is negative and the other one is positive. So we're going to use the positive one when it hits the ground, which only takes about 2 seconds to hit the ground. When can you, how can you use the calculator to calculate it? We'll find the x-intercept. I could find it here. So when it hits the ground, I should just zoom out, but I have not. Okay, so here it is. Ooh, 1.75. Why do I keep getting the wrong number? Okay, at 1.75 seconds, what did I get? 2.03. Did I put any numbers in wrong? So the negative 24 was right. The 48 was right. The negative 4 was right. Negative 16 is the A value. We better double check. 24, yep. And the 7 was his initial height. Okay, so that looked good. Oh, right here. I keep putting the wrong numbers everywhere. Okay, so this should have been my A value. This should have been negative 16, which changes this to negative 32, which changes our answers. Recalculate. We already know what one answer is. It will be 1.75 seconds, but let's try it and see if we get that. So negative 24 plus the square root of 2752, hit enter, divided by negative 32. All right, so one is at negative 0.889 feet, and negative 24 minus the square root of 2752, hit enter, divide by negative 32. Let's try it again, negative 24 minus the square root 2752 divided by negative 32. Oh, I keep getting... Okay, well, it should be 1.75 feet. And again, we saw how to... Oh, seconds, not feet. And again, on our calculator, let's just see if I typed that in right. Yep, negative 16, 24, 7, Here's where it hits the ground. Height of 0. So I just typed something in wrong here. Negative 16. That's right. Oh, yeah. I found my other mistake. There was one more. And that was right here. This should have been not 48, but 24 is my B value. Okay. So recalculate one last time. So change this number. So the new discriminant is 24 squared minus 4 times negative 16 times 7. Okay, so this is 1024. So I have negative 24 plus the square root of 1024, 1024, divided by negative 32. Okay, so one of our answers is negative 0.25. That's the negative. And then negative 24 minus the square root of 1024. Hit enter. Divide by negative 32. There's the 1.75. Okay. So make sure you have your correct A, B, and C value, which I did not for this problem. Better make sure I had it for all the other problems. Yeah, that looked good. Okay. So your goal is to do the basketball problem. So to find the vertex, can you find the vertex? Go back to this. Remember, we have x equals opposite b over 2a, and then plug in to find the y value. Can you find a height of 10 feet, where you use quadratic formula, but you have to set it equal to 10, and then get 0 on one side? And then can you find where it hits the ground, which is the x-intercept, again, using quadratic formula? So you're going to try that 3 times, because we have 3 different players here with different values. We have Feza with an initial vertical velocity of 22 feet per second and a release height of 8. Olea has an initial vertical velocity of 20 feet per second and a release height of 7. And Aaron has an initial vertical velocity of 24 feet per second and a release height of 9. So the first question, at what time does the ball reach a height of 10 feet? We'll set it up for Feza. So for Feza, I'll just put y equals, you can put h of t equals. So we have negative 16 t squared for all of them, because that's gravity. But her initial vertical velocity is 22 feet per second and a release height of 8. So here's the equation. And when it reaches a height of 10 feet, set it equal to 10. Get 0 on one side, use quadratic formula. For Alea, again, negative 16 we start with for gravity. She has a vertical velocity of 20 feet per second and an initial release height of 7 feet. And for Aaron, same starting value, negative 16t squared, vertical velocity 24t, and a release height of 9. Okay, so go ahead and use this and do question 1, which corresponds to what we did in the notes. Question 2 is the vertex. Question 3, when does it reach the ground? So your assignment is to finish the next 2 pages, 18 and 19.